Hey guys, welcome back to my channel. So today I decided that I would make a more math video. Now this problem is a high school competition math problem, which is geared for 9th to 12th graders. So this problem's asking, suppose a, b, and c are the roots of f of x, and f of x is equal to x cubed minus 5x squared plus 12x plus 1. Find, those fractions there. Now, initially what a lot of students would do is they would try to simplify that really disgusting fraction. But if you know Vieta's formula, solving this problem is really easy. So Vieta's formulas are a list of formulas that can be used on polynomials if you know their roots. Now, we don't know the roots, but we do know Vieta's formulas, and Vieta's formula states that the sum of roots is equal to negative b by a, and negative b by a are the coefficients in f of x. Additionally, the sum of pairs of roots is equal to c by a, and the products of the roots is negative d by a. So, in our f of x, we do know that a is equal to 1, because that is the coefficient in front of x cubed. Since x cubed doesn't have anything in front of it, we know that it's 1. Additionally, b is negative 5 because that's a coefficient in front of it. C is 12 and d is just 1. Now, applying our values of a, b, c, and d in Vieta's formulas, we know that the sum of roots in f of x is 5. We know that the sum of pairs of roots is 12, and the products of the root is negative 1. Here's the part that requires a bit of algebraic manipulation. We want to find a plus b plus c whole squared, which is 5 squared, and that's equal to 25. Now, we know that a plus b plus c, when we write it all out, it's equal to a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. We know the sum of pairs is 12, and 2 times 12 is 24. But we don't know what a squared plus b squared plus c squared is, and that's what we want to find out. So what I did was I did 25 minus 24 is equal to 1, and that's what a squared plus b squared plus c squared is equal to. Our main goal is to find out what that really ugly fraction is. And since we know that a squared plus b squared plus c squared is equal to 1, what we can do is we can make the fraction look a little bit better by finding the values of a squared plus b squared and a squared plus c squared and b squared plus c squared. So, because we know a squared plus b squared plus c squared is equal to 1, we can say that a squared plus b squared is equal to 1 minus c squared, so that we can set the numerator of the first segment of that really big fraction to 1 minus c squared. So we can write 1 minus c squared over c squared for the first part of the fraction. Next, what we want to do is we want to find out what a squared plus c squared is equal to. A squared plus c squared is just equal to 1 minus b squared. So we can write 1 minus b squared over b squared. And same goes with b squared plus c squared. b squared plus c squared is equal to 1 minus a squared over a squared. Now again, doing some more manipulation, we can get 1 over c squared plus 1 over b squared plus 1 over a squared minus 3. Now we want to simplify those reciprocals so that we have the product and the sum on top. How we can do that is just by combining all those reciprocals, and we'll get this fraction in red. Now, this fraction in red, as you can see in the denominator, it has a squared, b squared, c squared, and with our Vieta's formulas, we know that a, b, and c is equal to negative 1, and negative 1 squared is just 1. So, what that fraction on the left is equal to just a squared, b squared, plus a squared times c squared, plus b squared times c squared. Now, we know that a squared, b squared, we want to figure out what that numerator is, and what I noticed was it awfully looked like AB plus AC plus BC whole squared, but it isn't. Because, as you know, with AB plus AC plus BC whole squared, there are a few extra terms. So you can see I'm just simplifying that, and when you simplify that, the first part looks awfully similar. But as you see in the second part, the numbers I'm writing down right now, 2a squared bc plus 2ab b squared c plus 2abc squared, that's not included in that. So we want to figure out what that is so that we can subtract it. Now, we know that these, we can rewrite it so that we can have a squared b squared plus a squared times c squared plus b squared times c squared. And we know that's just 2abc times a plus b plus c. Now with Vietas, we know that a plus b plus c is just equal to 5 because that's the sum of all the roots. And also with Vietas, we know that abc is equal to -1. So it's 2 times -1 times 5. So here you may be wondering where I'm getting the 144 from. Remember, we're doing AB plus AC plus BC whole squared. And if we look in our green, we see that AB plus AC plus BC is equal to 12, and 12 squared is 144. For my lack of space, I wasn't able to put everything on one screen, but make sure you don't forget the -3. If we look on our previous, what it was, 1 over c squared plus 1 over b squared plus 1 over a squared, there's a -3 there. So we can't forget to subtract that, on our right side of our equation. So we know a squared b squared plus a squared c squared plus b squared c squared is equal to 144 plus 10 minus 3. And as we found out, that really ugly fraction is equal to 151. I hope you guys enjoyed this video. If you have any questions, leave a comment. And if you want more videos like this, please leave a thumbs up. Thanks for watching.